change problem on the first question. To me, the challenging parts, Henry and Scott, is the reading. And also think about it. Well, first off, I have a table. Just look at the problem. Okay, girls? I'm teaching test-taking strategies. There's a table there. Probably have to find a slope. Without reading the question, if you have a table, you probably need to find the slope. Okay, says the temperature of water in a tub is modeled by a strictly increasing, which means it's increasing everywhere. The first and second derivative exist. All those things mean something. And W is measured in degrees Fahrenheit. Now, it never hurts you to include the units if they don't ask. So always include the units, because if they do ask and you forget to include the units, you're going to lose points. Even if you have the wrong units and they don't ask you for units, there's no penalty. Okay, Rachel? Kobe? Okay. At time t equals 0, the temperature of the water is 55. They give it to me in the table. They give it to me in words. The water is heated for 30 minutes. Now, look at the table and think for a moment. The water starts at 55 degrees. After 20 minutes is what? 71. So if you get an answer that it's heating up at a rate of 1,500 degrees per minute, is that reasonable?
Yes. Totally.
Well, we got a lot of answers like that. I graded this one.
Really?
I'm serious. Well, we did have some good chuckles, I'll admit that. The water's heated for 30 minutes, and it says they give you the table of values for the first 20. Use the data in the table to estimate W prime of 12. Show your computations using correct units and interpret the meaning. How are you going to find W prime? Alex? Okay, you need to be everybody needs to be doing the problems. If you're not going to do the problems, I'm going to remove you. Go, where's your pencil? Do you need one?
I wouldn't look at that.
No looking. You have to perform.
Okay, fine. First,
what's W prime of 12? What's it asking?
Look at the change between equals, not equals. Or you could just do the average rate.
Okay, Alex is saying, look here, because 12 is between 9 and 15. So what is it, W prime of 12 asking for? It's a slope, right? It's an estimate. It's just an estimate. W prime is really the slope of the tangent line. So what could you do? Find the slope at those points. We'll do it. Good. You have to simplify your answer. No. How many of these did I see upside down? A lot. You don't get the point if you just come up with the answer. You have to show your work. Even though it might be easy for you to subtract in your head or whatever.
Yes.
I don't know. Shall we check? You got to interpret it too. It says 67.9 minus 61.8. That was good enough over 6. Here, let me do this. Now I can slide this up. There, now can you see it? Just 1 point for that. But if you didn't show, if you don't show either this point right here or this one, you got 0. Now, some of you aren't paying any attention. Take advantage of the fact that I'm a grader. I'm telling you, you got nothing if you came up with the 1.017. This is a graphing calculator problem. But you have to divide? No. Because it's the change in W over the change in time. Is that okay? Now, what does it mean? What is W prime of T? It's the change in W. Now, you got to be very specific over the change in time. So what does it represent? What does it mean? If you were to explain it, somebody doesn't know anything about calculus or math, that is what? It's how the temperature changes. It's approximately how the temperature is changing at T equals 12. And using correct units. So what are the units? I think it said using correct units.
Degrees Fahrenheit per minute.
Okay, so it's going to be degrees Fahrenheit per minute. Let's see if we got it all. I don't know if we got it all, but the water temperature is increasing at a rate of, and you could just use this if you want. You don't have to get the number out there. Per minute at time t equals 12. So you have to have the 12 minutes, and you have to have the degrees per minute, and you really should say it's increasing. Had it been negative, you would have said it was decreasing. So there are always three things I'm looking for when I grade that problem. Okay, so that's only 2 points. Let's go ahead and finish the problem. I don't know what the next question is. It's not that bad. Oh, use the data in the table to evaluate the integral of w prime. Using correct units, interpret the meaning. Well, what is the integral of w prime? Whoops. The integral of w prime of t, and where is it from?
0 to 20.
0 to 20. What's the antiderivative of w prime? This is so easy, you're going to die on it. It's just w of t, and what theorem is this? Close. It's the fundamental theorem. Actually, it's the second in some books, so you're right. Okay, out of the table, we have to read those values. And what does it represent? Think about what it's talking about. This is the degrees Fahrenheit at 0, and that's the degrees Fahrenheit in 20. So it's how many degrees the water temperature has what? Changed, right? Yeah. Because I think we had to interpret it. I don't know for sure. It says, yes, interpret using the correct units. So I need W of 20 and W of 0. So it's 71 minus 55. That's good enough. You don't have to subtract it. Subtract it wrong, you lose the points. And it means it's the change in the water temperature. The water is warm 16 degrees from T equals 0 to T equals 20. You have to do the problems because what's going to happen is when you get to the exam, you're going to say, well, how much do I have to write down? Well, you got to write all this down. You have to talk about what this represents. It's 16 degrees. It's warming from 0 to 20. I got some crazy, crazy answers, like 1,000 degrees. Doesn't even make sense. Now, that's 4 points. Was that hard?
Not really.
Not really. Have we ever really, the only calculus we've done is really this. So you might want to write down someplace that the integral of f prime of x dx is equal to f of x plus c if we're not using the fundamental theorem. Okay, so you got some more work here to do. We talked about this yesterday, Scott. The average temperature of the water in the tub, they even tell you this. This is the average value of the function. How do I know it's not the average rate of change? First off, they gave me an integral. But it says the average temperature, and what are we going to do? We are given the temperatures. Those words match. So it's an integral. But they gave it to me because they didn't want to see me get it wrong. Use a left Riemann sum with 4 subintervals to approximate that integral. What does that integral represent? Doesn't ask you to interpret it, does it? It's the what? It's the average temperature of the water during the first 20 minutes. What should the temperature be? Between what two values, Evel? What should the water temperature be? What kind of answer should you get? No, I'm just asking for an estimation. What kind of answer should you, if we're averaging the temperatures 55, 57, all these here, what should your answer be between? Between 55 and 71. So if you have 710, you did something wrong, right? Okay? Well, I mean, who knows what you did? I'm just saying it's not reasonable. So you guys do that. We're using a left Riemann sum. See if you can come up with it. Remember? You could graph this if you want, but you're just finding the area under the curve. Because you're going to use this for your height, the left endpoints here. So you're not going to use the 71. If it was a right Riemann sum, you wouldn't use the 55. Because if you can certainly graph it. A number of students did graph it. 0's at 55, 4 is at 57, 9, 61, 15 is at 67.9, and 20 is at 71. So we're going to use the left Riemann sum. So it's this one. So what's my height? For the first one, it's 55. What's the width? This is the left. If it hits on the left side. Pardon? Because they told us. They said use the left. Why did they tell us? Because they don't want us to have to be grading forever. So you guys tell me what the answer is. This is 4. What's this answer? What's that? 5. This is 6. And this is 5. You need to do it. This is what we do in study sessions. We come in here and we do problems. So sitting back like this doesn't do you any good. You need to do them. So do you need some paper? Val, do you need some paper? Yeah, do it. Can you read it? Is it too small? The left side is 55. Then it's 57.1, 61.8, 67.9. You must show how you arrive at your answer. Look at the picture that I drew here. You got to look at the picture that I drew. You should make a little sketch to know. Maybe, I don't know. I just draw the picture. I don't believe in memorizing, so I don't do that. But you have too much stuff to know. It depends on the concavity. Or the increasing. No, it depends on increasing, decreasing. I don't know. I just draw the picture. So is it an underestimate or overestimate? Under. Did you get an answer? Evel, I don't see your pencil going. You guys, I have no control outside of this classroom. But in this classroom, you need to be doing the problems. No, not watching. That's not doing. I can watch baseball all day long, and I'm not going to ever throw a knuckleball as a pitcher. Never. Never going to throw a fastball. I can watch it all day long, but I'm not going to do it. Look at the golf and the Masters. Do you think those guys just walk on the course and yeah. No, they don't. Yes. Tiger Woods practices 8 to 10 hours a day. Yeah. Maybe. Which way do you want me to do this? This way? Sarah, which way? Put your phones away. Well, you can look up the answers. Alex, you need to be doing this. I'm sorry, what? You want to see C? Alex, you need to do it.
I didn't.
No, you haven't.
I told you what I do for A.
No, you need to do it. Okay. Don't forget to divide by 20. This line here is good enough. But most people got the right answer with the calculator. Most people got the 60.79. That's possible. Okay, you get 1 point for knowing what a left Riemann sum is. So 1 point for using this W of 0, W of 4, W of 9, W of 15. I'm trying to remember. I think you might get 1 point out of the 3 if you did a right Riemann sum. No, it's hitting on you're using the height, using the left side of the rectangle.
Yeah, this one is the only question. I always have trouble between right and left on this. Which ones are the over?
You write with your right hand. Well, I draw the picture. Because it matters. This is decreasing. If I hit a left Riemann sum here, this is going to be over. But if I do a left over here, that's under. If it's increasing, it's going to be under. If it's decreasing, like here, it's going to be over. It's not the concavity. It's the increasing, decreasing. Val, you should be studying math. No, that's physics.
Physics technically is.
True, but it doesn't prepare them for the AP exam in math.
So wait.
No, it doesn't. Okay.
Then the right one would be, the inverse would be under and then over.
Correct. I just draw the pictures. You want to look at the table? Yeah, I'm trying to get there. Okay, we haven't done the under-over estimate. Yes. got to bring these packets, especially at night. Bring the packets. Okay, and it's an underestimate with a reason. Now, you got 1 point. You got really 2 points for this line that I just circled. You don't have to get the 60.79. That's nice to know. Most students don't know that. And they go and they simplify it, and they simplify it wrong. And then we just go, oh, just leave your answer. Because we don't like taking the points. We want to give you all these points. We'd like to give everybody 9 points, because that means you learned your calculus. Okay, the approximation is an underestimate because a left Riemann sum is used and the function's strictly increasing. Probably have to say the function's increasing, so I suppose we could put that in there, but I just draw the picture. Honestly, if it's increasing, a left Riemann sum will be an underestimate. If it's decreasing here, it will be an overestimate. Regular form. There was no B form in the year 2012. Okay, let's look at D. Yes, it's up there. That's it. Okay. Which one are you asking me about? For A? No, it's just the slope. It's asking for an average rate of change. Not asking for an average value, but an average rate of change. Slope. It's a rate of change. Hey, Jack, you should be doing this. Everybody in here can earn a 5, but you got to do the work. If you're not willing to do the work, no, then all bets are off. But I know everybody in here is capable of a 5. If you do the work. If you just sit and watch me do this, no. Okay. It says, here's w prime of t, some ugly-looking function. You can't integrate it. We don't know how to integrate that. I don't even think it can be done. Maybe integration by parts. It says, what's the temperature of the water at T equals 25? So I have W prime of T equals, what was it? Someone read it to me?
Really ugly stuff.
What is it? And we want to find out, we know that when T equals 0, W is equal to 55. So W of 0 is 55, and we want to find W of, what's the temperature of the water at 25 minutes? So you have to understand the question. So I want W of 25. Anybody got an idea how we're going to do that? I don't want W prime. Taylor? Plug 25 into what? This is W prime. This is W. How do you get W prime to go to W? Integrate it. W prime of T dt. By the way, since they've defined it here, you don't have to rewrite that function. And that goes from the known point, which is 0, to 25. This has been used over and over again. This is the fundamental theorem of calculus, which is W of 25 minus W of 0. So we're going to integrate this with our calculator, whatever that is, because you can do that, equals W of 25 and then minus 55. So how do you find W of 25? It's 55. We're on the right track, plus this integral of 0 to 25. Now, if you have a CAS calculator, and if you can integrate it, you could add plus C, but let me tell you, you will not get any points. The only way to get points on this problem is to use the definite integral. If you do the plus C version and you don't integrate it by hand, you get 0. Just telling you that. A calculator may only be used for a calculator may only be used for, without any justification, for n derived, FNINT, which is what this is, zeros and intersection points. Can't use it for max mins. You can't use it to integrate a function.
Well, technically we can, but it won't count.
It won't count. You have to do it with definite integral. And this one I don't think you can integrate. I can get my CAS calculator out and find out. I don't know how to integrate it. You need a CAS.
Can't you just type
Yes, but if you want to do the plus C version, you have to know what the antiderivative is. Right. I know, that's what I'm saying. Don't do it.
I would just go back. It would be the integral.
So I would put this into y1 and then integrate from 0 to 25. What mode should you be in?
Gradient.
It makes a difference because you've got cosine here. You want to be in radian mode. Did you try it? I don't have any calculators. Sorry, guys. Did you try it? By the way, don't expect to go into the exam on the calculator part without practicing the calculator.
Could you go through cosine?
0.06t. So if you're just sitting there not practicing that, you don't want to do it at night. Honestly, I think if you do this, even if you don't come to study sessions, you can still get a 3, 4, 5 on the exam. But you got to participate in class. Did you get to work? Is it? No, it isn't. It's 12:10.
Okay.
Okay, let's check. We're going to finish this problem. So, no, we're going to finish because it's not time to go. And let's see what the answer is. 73.043.
Wait.
Oh, I read the problem wrong. Wait. Oh, no, are you kidding? I forgot to read the whole thing. We're starting at 20 and going to 25.
That would have helped.
Yes, that's why you have to read the problem. So this is going to go from 20, and where's 20 starting?
No, I didn't say secondary.
That's 71. That's what I did wrong.
One moment. One moment.
No, you weren't confused about that. That wasn't the problem. Anyway, this should be 71.
Okay, wait, it's 20 to 25.
It's a good mistake for me to make because that's the mistakes you guys make. Yeah. Now you must integrate it.
Okay, wait. Question.
Yes.
I did not use the left wing. I did the actual integral, and I got it.
It doesn't matter. They asked you to use the Riemann sum. Up. I didn't read the question. That was my problem, which is good. But I made that mistake because guess what? You'll make that same mistake.
Okay, wait.
This function's only true between 20 and 25. How many points was that? 1 point for writing it as an integral like this, or the way I did it. You get your point, by the way, for writing it just like this. That's worth a point and a point for the answer.
I'm trying to see how they got 73.
So I think you can get, I don't know, I could look it up and see what the average was. I think I remember, I think the average in AB was about 3. Average in BC was 5 or 6.
Yeah, wait, it's going.
Well, they've seen it, some people have seen it twice, yeah.
Wait, 5 or 6? What's that?
Yeah, it's time to go.
What's the first out?
9. I'm talking about out of the points, yeah. I'm not.
You looked online and I.
We are going to look at 2011. Don't bring cards to class at all, or they become mine. In the backpack.
Oh, in the backpack?
Yep. Okay. Nice. I'll unlock it. Because I'm going to give you a chance to try this problem. Okay, the phones need to get put away. 2011 question 2. This is called the tea and biscuits problem.
The tea and biscuits, but we're not British.
We are this time. Okay, I want you to try it.
All right.
I'm not going to stand up here and teach it. Try it. Okay, it should look, you guys, if you're talking, okay, Scott, it should look remarkably familiar.
Maybe that's because it was just like the one we just did.
It should be just like the one we just did, which tells you that's why you need to do them. We finished 2012, number 1. This is 2011, number 2. It is a calculator active question. Why is what?
There you go.
We are focusing on topics, not on years. Okay, so I'm going to pause my recorder and give you a chance to do this. Okay, so if you have yours, you can write right on it, or get a piece of paper and try it. Remember, if you are going to change to decimals, I wouldn't. I would leave it negative 8/3. But if you are going to change, at least 3 decimal places. And you can't be penalized more than once on a problem, but you have 6 different readers. So you get penalized 6 times if you do that, if you don't have the right number of decimal places. Well, we can show you. It says use the data in the table to approximate the rate at which the temperature of tea is changing and show the computations that lead to your answer. Now, it didn't say anything about units, so if you didn't put units in, no big deal. You must have either this H of 5, that piece, or that piece. You must have one of those pieces. Are we ready to look at B yet? Now, you need to draw the picture if you don't remember what trapezoids look like.
If you don't remember what a trapezoid looks like, you should go back to geometry.
So this is 66. Then at 2, it's 60. At 5, it's 52. At 9, it's 44. Well, I'm not doing very accurately. And at 10, it's 43. So the heights of my trapezoids are all different. Here's your trapezoid. Okay, Brock? These are the bases. The heights are the bases. And then this height is 2. So this height is 2. This one's 3. This one's 4. And this one's 1. Those are the heights. It's not sitting on the base. That's the height, because they look like this. This is H. This is B1. This is B2.
You have labeled is the change in time.
That's right. That's this length right here. That's the height. No. The bases are the sides that are parallel. Of trapezoids, bases are the parallel sides. That would be these. So for the first one, it's going to be 1/2 of 2 times the sum of the bases, 66 plus 60. Okay, the question is, why do the trapezoids, when they break it down to, why not break it into a rectangle and triangle? Actually, you could do that, and this year they did give credit, but there was a lot of discussion about that, because in particular, they asked for the trapezoidal rule.
Yeah, I mean, in this.
Right, but they did give credit, but that doesn't mean they will this year. If we have a trapezoidal rule this year, they may say if you don't show trapezoids, you get no credit. In my opinion, that's the way it should have been done in the first place. Okay, guys? So are you ready to see that answer?
Sure.
Yep.
Yeah.
Okay, whoops, I don't want to go too far. So now it asks for using correct units. I recognize that as the average value of the function. So it's the average of the temperatures during the first 10 minutes. In what units? Degrees Celsius. 3 things. It's always 3. Okay. Sure, it's the same thing. So you could do it this way. It's the integral from 0 to 10 of h of t dt over 10. That's the same thing. Now, meaning of the expression, you had average temperature. Key word here is average. Degrees Celsius, 10 minutes. I always see, when I see these, there's always 3 things you're looking for to get that 1 point. That's all it's worth is 1 point for that. But you can't add them all up. I don't know. Here's the work. It's 1/10 because of the 1/10 out front, but it's 1/2 the sum of the bases times that 2. Then these are all halves. Then this base was, height was 3, 4, and 1, and you just add them up. I'd have to see what you did. You probably missed something. What did you get, 44? Okay. I don't know. First off, I wouldn't even use my calculator. That's all I would write down. You don't need to come up with 52.95, because if you don't get that last point. You get a point for showing you use trapezoids. Some people did rectangles and triangles and they got their point. And then 1 point, another point for the same thing, unless you want to go to the 52.95, but you don't need to, which is really nice to know. Okay, what's C? That's exactly like what we did before. How do you do that one? This one's very quick. What's the antiderivative of h prime? H. So this is h of t evaluated at 0 and 10.
That's what I did.
So it's h of 10 minus h of 0. What is that? Val, what does that represent? Evel?
What?
What is this? Just forget that you're in calculus class. What is this? This is the difference in what? The temperature at 0 and the temperature at 10 minutes. In what units?
In degrees Celsius per minute.
That's what it is. If you can write this, then just think about this in terms of the regular, everyday kind of math there is. The units are in Celsius, right? Because H is in Celsius.
Why doesn't it matter?
Because we're backwards. Okay? Now, it's a negative number, so, shh, you guys, it's a negative number. What does that mean? What has the temperature done if it's negative? Yeah, just like our spring. Temperature's going down. So it drops 23 degrees Celsius. There's three things. It's dropping, it's degrees Celsius, and the time is in the first 10 minutes. This looks just like the last problem. This is 2011, 2012. That's about it. The context has changed, but it's the same questions. Okay, did you guys get 6 points? If you're not getting 6 points, then you need to practice more, not less. Okay, you know, when I see this ugly looking function here and I see it's b prime, something tells me I'm going to integrate it. At t equals 0, the biscuits with the temperature 100 degrees were removed from the oven. The temperature of the biscuits is defined as this thing. Given the models, at t equals 10, how much cooler are the biscuits than the tea?
That's not.
What's the temperature of the tea?
That's not the temperature. That's the change in temperature, is it not?
It says the temperature of the biscuits is modeled B, and that's the rate of change. So how would you find?
Change, not temperature itself.
Right.
You do realize you said third.
You also do, right. Where do you see divided by 2? I'm not sure. How much, what is the T, what's the T's temperature?
T's temperature at 10 is 43 degrees.
Okay, so now we have to find the temperature of the biscuits at 10. We know what they started at. So you're going to integrate from 0, I'm starting in this right place, to 10 of b prime equals b of 10 minus b of 0.
Yep.
So b of 10 is going to be b of 0 plus that integral. There it is, 100 degrees plus that. So there's 34, and the t was how much, 43?
Yeah.
And all you had to do was even say this, 43 minus 34 point, no, you actually have to integrate it.
Well, you actually have to write all that. You can't just leave it as 43 minus 100 plus the integral.
No, you must integrate, must. Yes, because what's the integral of b prime? It's b. From a to b by the fundamental theorem is this. Oh, because they said how much cooler are the biscuits than the tea. You have tea and biscuits. The tea's temperature, yeah, that's what I'm saying now. The tea's temperature is here. They don't tell you anything about the biscuits until the very last question. Pardon? Yes. You can integrate that by hand. That is the one. Okay, you guys, I graded this one. And that's the one that students use their CAS calculator and integrated that and put the plus C in and found the C. You can do it that way if you know how to integrate it. Now, I claim that students could do this problem, integrating it by hand, without showing any work, because I can.
Wait, did they like skip a step in showing that they like added?
No, they didn't write it the way I did, like here. But if you add b of 0 to both sides, that's what they did down here. Where is this? That's b of 0 plus that integral. But I'm trying to point out, and I argued with them. I said, you can do that integral in your head if you have a calculator, which is a regular calculator. And they said, no, we assume they use the CAS calculator. And it was very clear that in different schools, they were doing these that way, because everybody from that school did the problem the same way. Yeah, I'll slide it up. So if you can get, if you can get six points, you're doing great. You can always go onto the College Board website and look up what the average score was, because it's there. And then you could look at the remarks about it, what students did wrong. And I don't remember, my feeling is, because this was like 2 years ago, is that they don't know the fundamental theorem. I know a lot of people did the triangles and rectangles there. Rated pretty easily, actually. Higher, like that. Now, the other thing we haven't done is a related rate problem. Was that? I thought it was 2008. Oh, snow problem's a fun one. Yeah, 2008. 2008, and we may not get this finished, but you should do this for tomorrow if we don't get it finished. And you certainly can do, if you notice that these problems are very similar. 2008 number 2 is another problem very similar to this. So master one type at a time. I honestly think that's the best way to do it, because remember the question is, how do you want to do it? It's almost exactly the same. Estimate the rate of change, use a trapezoidal sum. Then there's a little bit different question there, and then the last question is similar, yes. This? It's whatever that equation was. It's right there. And you may write b prime of c instead of writing the equation out. Yeah, you integrate from 0 to, because you're given 0, you know that, to 10. So it's an equation. You know this one, and you know that one, therefore I can find that one.
Can we move on?
Yeah, we're going to do 2008. You can do number 2 about the concert, but let's do the related rate problem, which is on number 3.
Breaking complex fractions is the limits.
No, because they're not going to be on the exam, so why bother?
You guarantee they're not on the exam.
I doubt that they are. Find them in a free multiple choice question, because that's where it'll be. Uh-oh. We only have 4 minutes. Let me bring it up, and I'll show it to you. You have all the solutions, but don't use the solutions. Try the problems first. And this one's kind of scary looking. That's number 3. Whoops. That's number 2. That's the one similar to what we just did. There's 3. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick. Would you know what happened after this problem was written? This problem was written in 2006.
There was an oil spill.
And where was it?
Somewhere.
Gulf of Mexico. The BP oil problem. This is the BP oil problem. Yes, we all care about it because it ruined the environment, and BP paid millions of dollars. And this is the same kind of problem it is. It's a related rate problem.
So BP didn't know their calculus.
Like, after they had the oil slick, they probably used, their engineers probably did use calculus to figure out how much oil was being used. Why do I know it's related rates, besides the fact that it has a lot of words? It has volume in it. It has instant when the radius is. Do the find, given, when. Well, what is it we're given? They give you the formula for the volume. It says at an instant, and I won't be able to save this because that's on a PDF file. At the instant when the radius is 100 centimeters, so W is R equals 100 centimeters. The height is 0.5 centimeters. The radius is increasing at a rate of 2.5 centimeters per minute. What is that? The radius is increasing, dr dt. And what does I want to find? What's the rate of change of the height? So I want to find dh dt. So I need to relate h and r. Do I know dv dt? Oh, I do know dv dt. What's dv dt? 2,000. Now, I don't care about the units. Now, you guys, I want to relate R and H. I'm going to have to use the product rule on this one. I know, product rule. Does it ask for the units? Is there any question where they ask for the units? Where? No, it doesn't say including units.
Yeah, in centimeters per
It
minute.
doesn't say including units. Explain your answer with the correct units, or find the answer with the correct units. It's got to say it.
But can you use it or no?
You certainly can. It won't hurt you even if you do it wrong. Last year they included units, but the other 2 years there were no units to look at. We just ignore them.
Where do you go to grade all these?
What?
Where do you go to grade these?
Kansas City.
Why Kansas?
Because they have a big convention center. There's room for biology and us and a whole bunch of other people. It's a very busy place when we're there.
So I have a question. When I get that 4 and or 5, where will you be taking me?
I don't care.
Hawaii. Yes, instead let's take a vacation to Hawaii. I